look at this triangle ABC. We know angle BCA is 90 degrees. We know angle BDC is 90 degrees. In other words, CD is the altitude to the hypotenuse. The length of CD is denoted as H. The length of BD denoted as X. The length of AD denoted as Y. Then we know A squared equals X times C. In other words, A is the geometric mean of X and C. B squared equals Y times C. In other words, B is the geometric mean of Y and C. Then H squared equals X times Y. H is the geometric mean of X and Y. We can prove these equalities using similar triangles. Triangle BDC is similar to triangle BCA by angle-angle similarity. Angle B is a common angle. Both triangles are right triangles. Therefore, BD over BC equals BC over BA. BD is X, BC is A, BA is C. Cross multiplication gives us A squared equals X times C. Similarly, triangle ADC is similar to triangle ACB. Therefore, AC over AD equals AB over AC. AC is B, AD is Y, AB is C, AC is B. Therefore, we have B squared equals Y times C, which is the second equality. Now, triangle CDB is similar to triangle ADC. Therefore, AD over CD equals CD over BD. AD is Y, BD is X, CD is H. Therefore, H squared equals X times Y. In summary, we have A squared equals XC, B squared equals YC, H squared equals X times Y. These three equalities are very useful to solve problems that involve right triangles. Now, let's prove Pythagorean theorem using similar triangles. Look at triangle ABC here. We want to show A squared plus B squared equals C squared. We know that A squared equals X times C. B squared equals Y times C. So A squared plus B squared equals X plus Y times C, which is C squared. You see, Pythagorean theorem directly follows from the three equalities we proved in the last slide. We proved Pythagorean theorem using similar triangles. Here, we use algebraic methods to prove Pythagorean theorem. We put four triangles with legs A and B together in this way. Then this angle equals this angle equals this angle equals this angle. And these four gold angles are the same. Because these triangles are right triangles, we have green angle plus gold angle equals 90 degrees. Therefore, these angles must be 90 degrees. So, in the middle, we have a square. The total area of the big square is side length squared. So, A plus B squared, which equals A squared plus B squared plus 2AB. We can also calculate the total area by adding different parts. We have 4 triangles. Each triangle has area A times B over 2. And we have a square in the middle with area C squared. So this is C squared plus 2AB. These two quantities must be the same. Therefore, we must have A squared plus B squared equals C squared. This is the second proof of Pythagorean theorem. Now, let's look at another proof, which is similar using algebraic methods, but slightly different. We put 4 triangles together in a different way. This side is A, this side is B, and this side, the hypotenuse, is C. Then the area of the big square is C squared. It equals the sum of the 4 triangles plus the little square in the center. The area of each triangle is A times B over 2. 4 triangles, so we multiply by 4. The area of the little square in the center is A minus B squared, because this is B. Therefore, this is A minus B. The side length is A minus B. We simplify the right-hand side of this equation. We get 2AB plus A squared minus 2AB plus B squared, which is A squared plus B squared. This is the third proof of Pythagorean theorem. Now, let's look at Euclid's proof. We have triangle ABC. Now, the hypotenuse in this figure is A. The 2 legs are B and C. We draw 3 squares on each side of the triangle. We connect FC, we connect AD. Then triangle FBC is congruent to triangle ABD by side angle side. Each triangle has a side with length C. Each triangle has a side with length A, and the angle between these 2 sides are the same, 90 degrees plus angle ABC. Therefore, area of FBC equals area of ABD. What is area of FBC? The base is FB. The altitude is length of AB. So area of FBC is FB times AB divided by 2, which is 1/2 of C squared. What is area of ABD? The base is BD. The altitude is BK. So the area is BD times BK divided by 2, which is A over 2 times BK. These 2 quantities have to be the same, which means C squared equals A times BK. Similarly, B squared equals A times CK. Therefore, B squared plus C squared equals A times BK plus CK, which is A squared. This is the 4th proof. One central idea of this proof is the area of this triangle equals the area of this triangle. And the area of the green triangle is 1/2 of this gray region. The area of the red triangle is 1/2 of the gold region. Therefore, the area of the gold region, which is C squared, equals the area of the gray region, which is A times BK. Similarly, the area of this square, which is b squared, equals a times ck. Add these two gray regions together, we get a squared. Therefore, a squared equals b squared plus c squared. The area of the big square equals the sum of the area of the two smaller squares. Now let's see a fifth proof. This proof is based on area-preserving shearing transformation. Let's denote the legs A and B, the hypotenuse C. Then the area of the blue square is a squared. The area of the red square is b squared. The area of the green square is c squared. We want to show a squared plus b squared equals c squared. What we do is we transform the blue square this way by moving the top side upward along this gray line. Then it becomes a parallelogram, and the area is the same. Then it will reach this point. Then we move this rectangle downward. It will occupy this blue region. So this blue region has area a squared. Similarly, we transform the red square. We make it a parallelogram first, the gold parallelogram. Then we push it downward. It becomes this green rectangle. Then we move the green rectangle downward. It becomes this blue region. So the area of this region is just b squared. Then you see a squared plus b squared equals c squared. If you click this link, you will see a movie about the transformation, which is a video proof of Pythagorean theorem. Can you think of any other method to prove Pythagorean theorem? You don't have to answer this question right now, but you can keep it in mind. In the future, maybe you come up with your own method. This is the end of the video.